So let's look at some graphing ideas out of section 4.5. Let's look at the graphs of tangent and cotangent. The tangent and cotangent functions. Okay, so again, this is going to follow similar graphing technique explored in some earlier notes videos and some techniques that you learned last year in Algebra 2, is that we're going to look at the parent function and then talk about if we have some shifts in a more complicated function, how can we relate that, those complications to the original parent function, and we could probably just change the parent function graph a little bit to create the graph that we want. That's going to be our general strategy. So let's look at the parent function, which is f of theta equals tan theta. Okay, so the graph is going to look like so. I'm going to draw one cycle. So there's one cycle of the tangent graph. It has vertical asymptotes at negative pi over 2 and pi over 2. And it's always increasing, and the range is negative infinity to infinity. Now, I could draw in more cycles if I desired. So for example, it looks like the space in between the asymptotes is pi. That's what the period is here. So I'll just note that down here. The period is pi. So that means if I wanted to draw another cycle, I would have to put another asymptote out here, but the spacing between pi over 2 and this next asymptote, that would have to be the same as the space between negative pi over 2 and pi over 2. Since that space is pi, this next asymptote would be at 3 pi over 2. The 0 would be right there at pi, right in the middle, and then I could draw in another cycle of the tan graph. And I could keep that going on the negative side as well. It would be at negative 3 pi over 2, that asymptote. Excellent. So there's the tangent graph. And then I could draw as many cycles as I wanted. Now, most of the time I just draw one cycle, and then any questions I wanted to answer, I could figure them out just by looking at one cycle. So usually the best cycle to draw is just the one that has the 0 right at the origin. That's like the best place to look at the parent function, and then we can take care of shifts and everything just based on shifting that first cycle around, shifting the 0 at 0, 0, shifting those asymptotes at negative pi over 2 and pi over 2 accordingly when we have a more complicated function to draw. Okay, so the period's pi, range negative infinity to infinity. No amplitude because the range is negative infinity to infinity. Domain's tricky here. Domain is definitely tricky because there's lots of different pieces. There's an infinite number of kind of unions I would need to write this domain. So I need to be careful here. So my domains. Well, I'll start off by writing just the domain of the most basic piece of the graph, the one that's right in the center. So the domain there would be negative pi over 2 to pi over 2 with parentheses because the negative pi over 2 and pi over 2 are where the asymptotes are. Now notice I'm leaving myself space there. So I have to account for, okay, yeah, there's an asymptote at pi over 2, but where does the next asymptote occur at? So the next asymptote occurs at 3 pi over 2, which is pi kind of down the x-axis. So I'm going to put plus pi n here. I'm going to do the same thing here. Now what that means is that if I plugged in any integer value for n, I would get a piece of the domain somewhere down the line. So for example, if n was 1, my domain would read positive pi over 2 to 3 pi over 2, which would be the second piece of the graph there, that second cycle over on the right. So this way of writing the domain is saying that it's an infinite union of these connected pieces, these disconnected pieces, because the vertical asymptotes are separating the graph up into an infinite number of like small domains. So we're just going to write kind of the most basic one, but then talk about how far the asymptotes are spaced apart to kind of write a general formula, or I'm sorry, a general expression for the domain. And I just need to denote here that n is an integer. So n, and then the scripted e means is in, and the z with the double bar means integer. So just some fancy notation here. The scripted e, epsilon, means is in, and that z double bar means the integers. So we're just getting some fancy notation in here. So let's look at cotan. So how about f of theta equals cotan theta? So cotan, similar graph. It's going to have an asymptote at 0, an asymptote at pi. It's going to be decreasing. So there's one cycle of cotan. So if I want to draw in another cycle, throw an asymptote over on negative pi. So there's my cotan parent function. So the period's pi. The range, negative infinity to infinity. The domain would be 0 to pi is that first piece, but then the asymptotes are spaced apart by multiples of pi. So I'll do plus pi n plus pi n, where n is an integer. Excellent. Okay, so now let's look at graphing some specific examples here. Okay, so let's say f of theta is 2 tangent of theta over 2. Okay, so now I just need to figure out what are those coefficients doing to my original parent function. Well, this 2, that's just kind of stretching out the graph. With sine or cosine, I would change the amplitude to make the graph taller. But in this case, with tangent, with the range going from negative infinity to infinity, if I stretch out the graph, I'm just going to kind of take some of the curvature away from it. So in terms of doing a sketch, I'm not going to see much difference with that 2 there, because that's stretching the graph vertically. The graph already has range negative infinity to infinity, and it already just looks like it is stretched out. So if I put the 2 there and I stretch it out some more, that's not going to be too much of a visual change in terms of just sketching. So I don't really have to worry about that initial 2. But what about this theta over 2? Well, that makes the b value 1/2. Now the formula for the period here is pi over b. It's not 2 pi over b. So tan and cotan have a different formula for period than sine, cosine, cosecant, and secant. So keep that in mind. So my period would be pi over 1/2, which is 2 pi. So I'm just going to draw a tan graph but now I need to figure out, since the period is 2 pi, that means the space between my asymptotes here needs to be 2 pi. So that means this first asymptote needs to be at pi right here, and this one over here needs to be at negative pi. So then the space between them is 2 pi. Perfect. So I've got my tan graph done. Now let's see if we can get what the domain would be here. So the domain would be negative pi to pi, but now the space between the asymptotes is 2 pi. So it would be plus 2 pi n plus 2 pi n, where n is an integer. Excellent. Okay, now let's go over to cotan. Try a cotan example. How about f of theta equals negative cotan of 4 theta. Okay, so what's that negative going to do? The negative is going to reflect it over the x-axis. So it's going to change it from decreasing to increasing. So that's going to change the cotangent function to be increasing instead of decreasing. That 4, that's the b value. So the period equals pi over b, which is 4. Can't reduce that at all. My period's just pi over 4, 45 degrees. Okay, so let's get a sketch going. So again, I'll sketch a cotan graph, but instead of decreasing, it's going to be increasing this time. Okay, so there's my sketch. And since the period's pi over 4, that first asymptote's going to be at pi over 4. Excellent. And I'll get the domain going here. Domain is going to be 0 to pi over 4. The space between the asymptotes is pi over 4, so that'll be plus pi over 4n. Plus pi over 4n. Where n is an integer. Excellent. So those are some good examples of how to graph the tangent and cotangent function.